Hi, I'm Muhammad Daniel, and I'm gonna tell you the introduction of our group presentation. Okay, the introduction is discrete mathematics is a field that focuses on the study of discrete objects such as whole numbers, graph, and reasoning. During these presentations, we will delve into the practical applications of logic in daily life and examine how it can be employed to address challenges and arrive at informed conclusions. This branch of mathematics plays a crucial role in the study of computer science and has numerous real-world applications in areas like algorithm, data structures, and computer networks. By gaining a deeper understanding of the concepts and principles of discrete mathematics, we can equip ourselves with the tools and skills necessary to solve complex problems and make informed decisions.
Okay, Assalamualaikum. My name is Nuradi Aiman bin Nuriadi. Okay, today I will like to share you my answer for this question. Okay, as you can see here, there are two variables in this question. So first we have to make a truth table. Okay, as you can see here, we have to fill in the truth table P, Q, not P, not Q. We have to fill it first. So truth, false, false, truth, false, truth, false, and not P. We have to choose the opposite output. So if the P is truth, so the not P is false. So false, truth, truth. And not Q, we have to choose the opposite of the Q. If the Q is T, so the not Q is false. So false, truth, false, truth. So and then P and Q, if the input has one truth, so the output will be truth. Okay, as you can see here, PQ, truth, truth. So the P and Q will be truth, truth, false. The P has truth, so the P and Q has truth. False, truth. So the output will be truth. F, false, false. So there is no truth, so the output will be false. Okay, and then we have not one, so we just write the opposite output. False, truth, 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 false. So false, 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 truth. Okay, and then two conditional P. You have to remember the truth, false. If truth, false, so it will be false. The rest will be truth. Okay, as you can see here, two conditional P right here. Okay, so the output will be truth, 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 false. And then not true, we have to choose the opposite outputs. So false, 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 truth. Okay, and then not P and not Q. False, 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 truth. If in this section we have to remember only if truth, truth, so the output will be false and the rest will be truth. Okay, so it will become F, false, 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 truth. Okay, and the last one is not tree, bioconditional, false. If and only if the output is truth, 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 truth. Okay, and then we have to make a segment statement. Statement. Okay. Not. So we have to write back the. Okay. So okay. For the statement. For the statement, we have to write back the question. First we have to look at the truth table to make sure if the values are the same. So if you can see here, the values here, false, 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 truth and truth. So the values are the same. So we have to make a statement. Not in bracket, not P and Q, conditional P are equals not P and not Q, because the truth values are the same. Okay, so that's it from me.
Hi, I am Muhammad Daniel bin Abdul Rahman, and today I'm going to show you how to solve logic expression using logic circuit and logic laws. Okay, first I'm going to show you the logic expression. Here's the logic expression. As you can see, it's P and not P or Q. This symbol is what we call conjunction, and this symbol is what we call disjunction. Okay, whenever in logic circuit, whenever we encounter the symbol conjunction, it means that the logic circuit is in serial circuit. And whenever we encounter this disjunction symbol, it means that the logic circuit will be in parallel circuit. So here's the logical circuit that I've drawn. Okay, as you can see here, not P or Q, this junction is in parallel, so we can draw it like this. Not P and Q is parallel circuit, while P conjunction them, this expression means that it is serial towards this parallel circuit. So we can draw it something like this. P is serial to this parallel circuit. So we need to also draw A and B as in logic circuit. We need some we need the input to go to one place. Next, we're gonna solve this same logical expression using logic laws. Here, as you can see here, P, same logical expression. First, we can apply distributive law like this, where P and goes inside the not P or Q. So first, we can see here, P and not P or P and Q. This P and will encounter this not P, and then this junction will become the middle term, and then P and will go to Q. Then we got this. Okay, from here, as you can see, P and not P, whenever this the same variable, where the first one is the normal one and the second one is negation, they counter and together, they will get contradiction. So from here, as you can see, as I already said, as we encounter this, it will become contradiction. This is inverse law. So as you can see here, P and Q doesn't change anything since we can't do anything about it. So the only thing that changes is this contradiction using inverse law. And whenever P, any variable meets or contradiction, we can use identity loss. Identity loss will make it that we can say it will make this contradiction disappear, and then it will leave out the only variable here. So that means that we use identity loss like this. So the only thing that left is P and Q. So that's all that we can do in here. Holy cow, I don't know how to answer this kind of question. Good morning, sir.
What? Oh, yeah. I'm listening to Never Gonna Give You Up by Rick Astley.
No. I want to ask you a question. Can you help me by solving this kind of question?
Wait, what? Hold up. Let me see. Easy peasy. Let's go.
Easy.
Okay, first of all, in order to answer this question, you need to have pen and another pen. That's just one pen. Okay, first of all, this question is about laws of logic. Okay, can you grab me my book like that? Okay, nice. First of all, if you got the question, you need to read it first. Most people doesn't read the question and they just do a simple careless mistake. So yeah, it's hard for them to solve the question. And this question, you can solve it by using a formula.
It has a formula?
Yeah, we do, of course. Every math question have a formula. So the formula, we have two formulas for this question. First of all is the validity of argument formula. And the next one is the laws of logic. You need to use and remember about this, both of these formula. Okay? And how you want to solve this question? First of all, it's easy. Why? Because first thing first, read the question and you just write it back. Write the question back. Okay, just like this. For example, P S and just write like this. You need to write the first step, the second step, and the third step because you have three questions, and this is the conclusion. Okay, so and then you just write it back. P S R and then not R, something like this. So you got the question, just write it back, man. Just write it back. And then you just need to write this one. P1, P2, and P3. This one is hypothesis. Yeah, like this one, hypothesis. P1, P2, and P3. Which if the question give you 4 hypotheses, you just put another 4, the P4. But we only have 3, so you just put P1, P2, and P3. So you got it right. And the first thing, like the question, a simple question, how we want to solve this? What have something to do with this formula and how to solve this question. So in this question, we need to compare P1, P2, and P3. But for me, if you ask me how I want to solve this question, of course, we want a simple step, right? So for me, okay, let me ask you, which one do you want to solve first?
I think it's 1 and 2.
1 and 2. Yeah, for me, yeah, I will pick both of these because why? Because it looks much more simple, right? So if you watch the question, now we will look at the formula, laws of logic. This one is laws of logic, and this is the other one is okay. The first thing we need to refer to this formula, okay, validity of argument. So we look PSSR. Which one is the same?
This one.
Syllogism, yeah. So you just write it back. Just write it back. It's not that hard. So you will get the answer is. So this is the answer, but we're not done yet. After use of this question, we just need to take this out. Just take this out, man. Take this out and roll it back. Like right here, we just wrote something like we put we take 1 and 2, right? So just write it back, 1, 2, and then just write what formula you use. Syllogism, right? So yeah, just write syllogism in here. So it's done. So, but we're not done yet. Why? Because we still have both of these. We need to solve that. We cannot just let it like that. So we need to solve this. Like this question. Okay, now you look at 3 and 4. Can we solve this? If you found something that you cannot find exact answer, and we look at the laws of logic, which one is similar to this one?
I think it's the De Morgan's law.
De Morgan's law, right? Okay, now we will put De Morgan's law right here. We put 5, step 5, De Morgan law, change from here into this one, right? So it will be not B. And then what we will do, remove 3 and put a 3 here. So we will remove 3 because we already used this step. So we removed it and we put De Morgan law. Now look at 4 and 5. So the answer is De Morgan's law. Not R, not. We move to 4 and 5. Now look at the 4, 5. Simplify number 5 first. Put the step 6. After De Morgan's law, okay, now number 5 first. Not R and not Q. Can we solve? We have something similar in here. If you look closely, look at this. P and Q. It might look different, okay? It might look different, but it's just the same. We just put not in here. So basically, we just wrote it back. We will take not R and not Q. So we will have not R in here. Okay, forget about this part. And then we remove 5 again. We remove 5 and put 5 in here. And we just wrote back simplification. Yes. Okay. And the last one is P and R, not R. We only left 4 and 6, right? Modus tollens. Right?
Ah, I see.
Yeah. So put 7 step. You look this one, P R and not R. You will have the answer is P R not R. The answer is not P. Easy, easy, easy. And we put 4 and 6. Modus tollens. See? It's easy. Okay, now after you solve this question, this means if you tick everything in this step, you only have the last step, which is 7. So this is the last answer. Therefore, not P is valid.
Oh, something like that.
Yeah.
Can I write a similar argument like that, but a different one?
Or for something like P, or you can write something like that but different, but have similar answers. Something like not P above, in argument above is valid. Something like that. For me, I just write not P is valid. So this is the answer. It's easy, right? It's not that hard, right?
Wow, it's so easy. Thank you, bro.
You understand? You understand? You have a problem? You have a problem? Or no? Huh? You have any problem or not?
No.
No. Just that, right?
Okay.
Just go.